Hello everyone, good evening, and myself Varun, and today I'm going to present the topic what's going to be the conventional engine's future. So let's begin. Here we can start with this topic. Before going to start about the presentation and what we are going to know about the conventional powertrain, okay, let's start with the very much beginning. Okay, I was working with an OEM, and before going to what is an OEM, so you know the car makers, right? Like Volvo and Toyota and Mercedes. So several bunch of car makers are there. Many of them from Germany are also there. And so the thing here is like the one who produces their own equipments, and they will manufacture overall the vehicle is called as a OEM. So consists like a Volvo and other bench or other things. So let us say consider, if you consider like all the parts in a car not manufactured completely from a Volvo. Let us say there is a Volvo S60, but Volvo S60 doesn't contain all parts made by only Volvo. So it might take some kind of equipments from a supplier. So here comes the portion of a supplier. So supplier are many suppliers are there. So supplier are like they will be manufacturing only a very much small component. So they're not capable of doing a complete vehicle manufacturer, but they can actually make a small product like a airbags. Airbags one supplier. Bosch is a very good excellent supplier. It's called as a tier one supplier basically. So there are plenty of suppliers are there, so they will be giving products to the OEM, and the OEM will make a overall product of a car, and they will be naming on behalf of their manufacturer name, Volvo and all. So here is the way in automotive sector, especially this is how the business is going on. So the thing here is like, okay, let's start with the topic. So the topic is what's happening in automotive OEMs dealing with conventional powertrain. Okay, the agenda is an introduction about the conventional engines, what exactly the conventional engines means. So here in India, we can see that all most of the engines are like a conventional engines. That nothing but conventional is nothing but the gasoline engines. Gasoline nothing means this petrol, diesel. These are all like a conventional engines, and the other type of engines are called as an electric engines. Electric engines will never come under into conventional engines. Only conventional engines are like a petrol, diesel, other stuff. So these are basically, we are going to talk about the conventional engines and how the OEMs or suppliers have a job background about these conventional engines, and roughly how many people are working with this with respect to these conventional engines. We can briefly talk about in this session. And okay, let's go into the next topics, like what is an engine control system. It's a basic idea about what exactly the engine deals with, and what are the different sensors and actuators are connected in IC engine. Okay, here I wrote a term like an IC engine. IC means internal combustion engine. Okay, to give a background about a small background about this IC engine, internal combustion engine are nothing but, so there are two types of engines. One is like a external combustion engine and internal combustion engines. So external combustion engines, we know very old passenger trains are dealing with an external combustion engine. If you see, they will be using a coal as a fuel, and they will be pushing coal into the chamber. So the chamber burns actually this coal and gets an heat energy and converts it to the mechanical energy basically. So this kind of a old type of train engines are there, right? So these things are called as an external combustion engines. Internal combustion engine, you will never be able to see any burning anything from the exterior side. So let us say our bikes, our cars, you will not be able to see any kind of a fuel. You are just letting it in, and you're just burning the fuel, right? So in the similar fashion, so internal combustion engines are like a very much closed. So you cannot able to see what exactly is happening inside the engine. So that's the reason IC engines. And introduction about a vehicular network. So introduction about a vehicular networks is like a, let us say in a car. So in a car, basically you will be dealing with many, like a plenty of ECUs will be there. So what is called as an ECU is nothing but, let us say you want to handle a particular brakes. So how exactly the brakes are getting actuated? So there is a component called ECU which is sending a signal to you, like okay, you need to apply brakes whenever you are just pedaling the brake. Then in that case, exactly what is going to happen? ECU will send a signal to the brakes that okay, apply this 40% of brakes or 60% of brakes. So similar passion, exactly. So ECU is having a power of controlling the actuators. Actuators are here nothing but a brake here. So the thing is like, so ECUs mainly over be having control of the actuators. And introduction about vehicular networks is nothing but this only. So however exactly the vehicular networks are deals with like CAN, LIN, and FluxRay and most. So there is several types of communication networks are exist. Okay, and among them, these vehicular networks are part of it. So diagnostics and vehicle and standards. So we also get to know about the diagnostics. So a brief intro about the diagnostics is like, let us say there is a problem came into a in your vehicle. So how you will get to know that which exactly the part is causing you the trouble? So there are million number of parts are there. So anything can happen in a car, and how you will exactly get to know about which problem exactly caused it to you? So in that case, diagnostics plays a vital role. Why? Because this diagnostics will tell us which is the exact problem to you. So that's the reason in vehicle they implemented diagnostics. So we will also go through a diagnostics in vehicle and standards. And coming to that OBD2. So what exactly the OBD2 deals with? Like, so there are a certain portion and certain services are there how you can read the diagnostics. So you cannot simply just connect some kind of a subsystem and read the okay, what are all different problems are there in my car. So it is not at all possible in that way. So only is a protected diagnostics. So how exactly you need to request some information from the vehicle is always deals with this OBD2. And error memory management and troubleshooting. So this error memory management is something like, as I said, there are errors. Errors are nothing but a failures. So let us say poor braking, poor acceleration, or anything whichever you face. Let us say you turn a light and it was never turned on, or some kind of a jerks you're able to feel when you're pushing the act pedal. So everything is an error. So everything will be having a fault code. So those things, how you are exactly dealing with this error memory, so that is being there in this error memory management and troubleshooting. So the last one is like a EOL diagnostics and calibration. So what exactly this EOL means? End of line diagnostics. So EOL side, okay, to give an intro about it. So you are taking your vehicle for a servicing. Let us say they might tell you it is a first servicing. You might get a mileage of very less. Let us say 10 to 15 you might get, and second servicing you will be able to get 15 to 20 they might promise you. But what exactly is going to happen? Why it is exactly increasing the mileage? How it is possible? So this is might be a curious doubt to everyone. So the thing is like they will be calibrating the engine into a different level. So in the after second servicing, they will be calibrating it at different parameters. So that will exactly affect your fuel economy, and indirectly your mileage will be getting impacted. Like your mileage will be improved basically. So that's the reason this EOL diagnostics are very much important. So these things, that is one such an example. There are plenty of EOL examples are there. And at last we can go through about the how this convention just are started in the automotive field, and what is the stage right now in the automotive field. So we can elaborate complete convention, just how exactly and the future how it will be. And going to the next one, career path and job opportunities. Yes, I will exactly tell like what are the different companies are available working in this automotive field, and what kind of people are perfectly suitable. Also, I will explain. So to talk about it, mostly electronics. EC, triple E people mostly applicable for this job opportunities. And there is a chance of a mechanical people where the designing things will be coming under, mostly deals with this electronics and triple E people. And at last we can go ahead with the Q&A sessions and we can end the session. So this is the just brief about the agenda, and let's start with the topic. Okay, as I said, introduction about the engines. So here you can see the GIF image where exactly it is telling about how engine is exactly working. So this talks about four different session in the. So how exactly there are different four strokes people will call. One is like an intake stroke, two is a compression stroke, and third is a combustion stroke, and fourth is an exhaust stroke. How exactly it is going to work? So this green portion you can able to see, that is an intake stroke. Whichever we have seen, whenever this comes green, this is an intake stroke. Intake nothing but the fuel and air mixer will be sent into the cylinder. This portion is completely called as a cylinder basically, and this one is called as a piston. So your piston will goes up and down, and which will exactly convert your linear motion. This is the linear motion to conventional motion. So this guy will be rotating round and round and round. So this guy is converting basically from linear motion to rotational motion. So this is how linear motion of mechanical energy is converting to rotational motion. And these are the four different strokes, are very easier strokes. Like first fuel will be injected, and your piston will goes down, and thereafter it will come back push. So what will happen here, the pressure is eventually increases. So this is the instrument called as a spark plug, which inject a spark basically. So this end of this compression stroke, basically the spark plug will be initiated. That means a little fire will be injected into the cylinder so that your fuel will be burnt high. So that's the reason the spark plug is playing an important role. And so what will happen is nothing but once this compression stroke is over, it will get a huge amount of energy because the fuel is burnt, and your piston will goes downside, and your this wheel is getting rotated. This is like a crankshaft basically, and this getting rotated round and round and round, and your wheels also getting rotated. So that's how exactly the engine should work. Your bike engine, car engine, trucks engine, bus engine, everything is the same philosophy, but with respect to different number of cylinders. Only bikes you will be able to see only single cylinder engines, mostly single cylinder engines. Some kind of Harley Davidson have some three cylinder engines, but mostly one cylinder engine. And some kind of engines are two cylinder engines too. There are there in different prototypes. And in cars mostly you will be see three cylinder in hatchback and four cylinder in sedans. So different six cylinder also is there in some kind of premium variants. So number of cylinders matters for generating the more power. So how many cylinders you have, it just multiplies the torque. So that is how the spark ignition engine, every engine, other engine works. And all these topics are we have already talked about. Internal combustion engine, external combustion engine, I just gave a small intro about it. Like these are all petrol diesel engines, and these are all the old train engines basically. So, and to give a brief intro about the liquid fuel IC engines, it's just discovered by 1872 by George Brayton. So it's a very old guy, and thereafter, the very next discovery by Mercedes only. And internal combustion engines are like two types of internal combustion engines are there: spark ignition engines and compression ignition engines. So here we talk about how exactly the spark ignition engines are works. So this is whatever you are going to see now in the GIF is nothing but the spark ignition engine, because it has a spark ignition engine. So it helps the fuel to burn to some kind of temperature. So the other way around, the compression ignition engines are nothing but, let us say there is no spark presence here. So the fuel just comes letting, and the piston goes up very frequently. So they will just inject the fuel many number of times. Let us say some 6 times they will inject, and this piston will go up and up and up, up down, up down, up down, and down. So what will happen? The compression will happen, and it will create a huge amount of pressure. That pressure alone gives you the temperature enough to burn the fuel. So first time, whatever the pressure required is a very much less. That's the reason they will try to pour more amount of fuel at the initial cranking, and after compressions, it will just ignite by the pressure itself. So there is no need of a spark ignition. So why exactly there are two variants of spark ignition and compression ignition? This might doubt might occur to you. So there are different types of fuels are available now. So diesel engines, petrol engines, both are different. So one is required, 100% sure requires your spark plug, but other thing doesn't require spark plug. Let us say gasoline requires a spark plug, diesel doesn't require a spark plug. Why? Because diesel itself can burn directly, because the burning temperature is less compared to the gas. That's the reason that diesel doesn't require any spark ignition system. So this is the way they actually classified. For more efficiency in diesel also, they are putting the sparks in some kind of a premium variants, not the every other variants, but people calls as compression ignitions. And okay, next going to the evolution in the engines, conventional engines, hybrid engines, electric engines. As I already mentioned, guys, like conventional engines are like a diesel and petrol, and hybrid engines. Okay, this term is like quite a new to you guys. So hybrid are nothing but, so it runs more than one fuel at a time. So let us say it's not only completely run by petrol, okay, or gasoline alone, or diesel alone. So that's the reason not only one fuel, there is another fuel combination will be included in this hybrid engines. Maybe electric plus conventional, maybe electric plus gasoline, or maybe kind of LPG and conventional, maybe. So there can be a different kind of a combinations. It should be a more than one. So that's the reason they actually included this hybrid engines. In hybrid, there are plenty of types are there: mini, micro hybrid, mild hybrid, full hybrid. So plenty of the things are there. But this is also one kind of type of engines. Electric engines are a way ahead. Like completely electric, there will be no use of this gasoline or diesel or LPG, nothing, only electric. So this is just a small intro about the engines. So what exactly the engine control system talks about? So the engine control systems are like, let us say, as I mentioned the initial example, let us say you want to control a brake, there should be someone to send a signal from a ECU to some kind of a actuator. So basically the actuators are getting controlled by your ECU. That's the reason ECU comes into the picture. So every other controller, like not only the engine have the ECU, every other system has the ECU. ABS has its own ECU. Brakes has its own ECU. So similarly, every different component in the car and vehicle, and even consider the steering, everything will be having a ECU, because it has to control the actuators. So that makes the component is in control to us. So that's the reason ECU comes into the picture. So talk about the engine control system. So engine has a plenty of components to control. Like it's the robust system in the car or a vehicle, and it controls. It almost has some 15 plus of actuators, and sensors are almost some near to 15 to 20. So plenty of sensors and plenty of actuators. You will not be able to see these many actuators, these many sensors with respect to other ECUs. Like let us say there is a power steering. Power steering is quite a famous in the cars now, and you if you just rotate a small little bit amount of turn, and it will actually rotate the vehicle to the bigger turn. So previously it is not the scenario. People use it to roll and roll and roll and the steering, then only the vehicle use it to turn. So but the actual efforts are reduced by the power steering ECU. So what exactly this guy is doing, it will just to push the steering into the more turns. Like there is an electric motor, if you turn a one time, it will actually turn the 10 times. So that is how exactly this ECUs are playing a very vital role in the vehicle. So I just gave a few examples which I talked now: engine ECU, body control ECU, transmission ECU, and ABS, EPS. So plenty of others I just mentioned, like what exactly they're going to control. Here body control covers doors, everything. And ABS, like an anti-lock braking system, we know it is the latest technology in the brakes. And EPS is like a electronic power steering. So this guy also quite a famous in the vehicles right now. And plenty of other issues are there. You can find if you put more cost, more number of issues will come. If you put less cost, obviously the number of issues will be reduced and the functionality also will be reduced. So engine is connected with a different sensors and actuators. This also I discussed. And sensors used in the engine are like a temperature, pressure, and position sensors. There are plenty different types of sensors. You guys know about the sensors, what exactly it is going to do, right? Like let us say the temperature sensor can measure the temperature where exactly it is being placed. Pressure is also pretty similar, and position is also similar. Why position and what is the position sensor, I will explain about further in the actuators discussion. And I also mentioned that actuators plays a vital role. As I mentioned, brakes, everything are actuators. It comes under the actuators and it plays a vital role. So there are plenty other like ECR, intake air throttle, turbo compressors. So plenty of others are there. We can get to know the introduction in the next slides. And okay, continuing to the engine control system. So now we are going little deep into with respect to the engine control system here. And you can see the picture right here. You will be able to see starts from the dynamic pickup unit, particular filter, EGR pipe, EGR cooler, emergency filter, EGR throttle, IAT, intake air filter, turbocharger, diesel engine, intercooler, other stuff, everything is there, no? And you will be able to spot the ECU, right? So every other guy, every actuator or every sensor will be connected to your ECU. So the lines will come to the ECU and lines will go from the ECU. So some are inputs and some are outputs here. So basically your car is like a closed loop system. So it exactly reacts whatever the signal you have given. If you push the act pedal some 20%, accordingly your engine will consume fuel, it will deliver the output power. So quite a similar way. So it is the here act pedal signal is your input, and the output is nothing but the power came into the wheels. So that is what the output. So very similar way here also the architecture being kept. So I have just listed down few of the components. So there are plenty of sensors as I mentioned: temperature sensor, speed sensor, and pressure sensor. And I also mentioned about the actuators. So ECR is a one actuator. This is like a exhaust gas recirculation. So we can talk about this right now. So you can able to see spot intake air filter, right? The rightmost side of the presentation. So from there exactly the air will be getting in. Okay. And from there the intake air will come into the picture to the intake manifold, and it will go up towards the intercooler. So intercooler may what it will happen like, so the gas might be a hot, the environment like a, let us say there's a huge temperature in the outside and your vehicle grabbed some amount of air and it came to the intake manifold, but it is not a it's quite a hot air. So it doesn't accept by engine because very hot air also will not be having a good combustion ratio. So that's the reason intercooler also will be kept into the picture, and it will just cool the gas whatever the amount it requires. So it will just cool, and you can able to spot air temperature, right? So that is like a sensor basically. So this sensor measures the temperature and it accepts the air into the cylinder. So the blue portion is the path which we are taking in the input side. So once the air enters here, the fuel also will be getting mixed there, and it will be injected into the cylinder. It will burn, and once right after the burn, the exhaust gate will come out of the engine during the red portion. So the red side is nothing but the exhaust side, because the temperature is so high. They are trying to represent with the red. So the exhaust gate will come downside and comes towards the turbocharger. So what this guy turbocharger is doing here? So basically, air will just cannot just enter into the intake manifold. So somebody has to grab the air inside the intake manifold. So what exactly this guy will do, this turbocharger will just push some kind of amount of air. It will just rotate fastly so that some most of the air will be getting sucked into the intercooler, so you will be getting enough air for your engine. Okay, and this turbocharger will take care about the exhaust gas. It will just push out the exhaust gas from the exhaust pipeline here. And so the exhaust gas will be going towards the particulate filter. So what exactly this particulate filter is doing here? So the burnt air, like the fuel burnt air, consists of a tiny black particles. People call it as a soot particles basically. So these soot particles they need to extract, because they cannot send everything, like every output which is after burnt from the fuel, because there are regulations in the every country. Let us say in engine there are different regulations, like a bar stage 4, bar stage 6, now BS4, BS6 people are calling, right? So these are all like a environmental regulations of for vehicles. So every time once the regulation is released by the government of India, then what they are going to do, so from your exhaust gas, if you are burning a 10 ml of fuel, okay, these many milligrams of carbon dioxide, these many milligrams of nitrogen, these many milligrams of soot particles should come outside. If they are coming more than that, then your engine is not applicable for BS4 type of engine, and they will never allow to release into the market. So right after passing these tests, then only these engines are coming outside. So this particulate filter will just extract the soot particles and helps to meet these regulations. So that is how exactly the particulate filter is doing. Okay, we have gone through the engine control systems, and now going to the sensors and actuators in the IC engine. Okay, here I just tried to plot sensors, different sensors and actuators located in the engines. So you can able to see starts from the blue side, mass airflow sensor. So how much airflow is getting injected inside the engine. So that is a quite important component to measure to perform the behavior of the engine, to calculate the behavior of the engine. And intake air temperature, so that is also quite important, because more amount of temperature gas should not let inside the engine. So that's the reason they're just measuring at the beginning itself. And after the compressor is there, compressor, I as I explained, compressor will help to reduce the temperature, and even to suck the air inside. And charge air cooler to reduce the temperature. You can able to see the bottom of the compressor. And the very next thing, air throttle position sensor. So you cannot let all the amount whatever you are just taken by the compressor. It is something like only some amount of air is required, only few amount of gas only you need to take it inside the cylinders. That's the reason you have a there is a air throttle will be there. So it will never allow you, it will just allow you 20% of gas which is taken by, or 40%. So how much amount it is required is depends on the ECU is the one who have the control of this air throttle. So for measuring the position sensor, whatever the position, 20% position or 40% position, so what is the position you have to know, in ECU has to know, right? So that's the reason they have injected a air throttle position sensor. Coming to the next, intake manifold, which has this intake gas, and it will just enter towards the green lines. So all the green lines are like, here you can able to find 6 different lines, right? One line is getting divided to 6 lines. That means it's a 6 cylinder engine. So 6 different ways, 6 different cylinders, this gas will be distributed and enter into the cylinder portions. So right after it burns, it will just come out of the red color lines. It is called as an exhaust gas. So from exhaust gas, the exhaust manifold it will just enter, and after entering the exhaust manifold, it has 2 different paths. So one is going upside and one is going downside. So let's talk about the downside path. You can able to find easier cooler, right? Easier cooler. So this easier cooler is nothing but exhaust gas recirculator. Why exactly this easier is being there, why we are reusing the exhaust gas? towards the intake side. So basically, it is already burnt air, already burnt air. So if it is burnt means there is no oxygen or very less oxygen, maybe 5% of oxygen or 10% of oxygen. So why we are injecting 10% of oxygen towards the intake side, which can effectively reduce the fuel economy. Why we are doing this intentionally? Why? Because let us say if you are, let us say you have injected 100% of fuel, okay, with 100% of oxygen, then what exactly it happens? The oxygen, it is more amount it is there, and spark will just ignite the fuel, and the oxygen is there, so it will happily burn the fuel. And what will happen? More amount of nitrogen will come out of the exhaust gas. So if it is a more amount of exhaust gas, it's a quite harmful to the environment. And your regulations of any country, like a India may it is BS4, BS6 and all, and in Europe side, Europe 5, Europe 6 and all. So they will never allow you to exhaust the more amount of nitrogen. They will just decide like for 10 ml of fuel burnt, you will be having a zero point 0.10 grams of a nitrogen should come outside. It should never come more than that. If it is coming, then the engine itself they will disqualify. They will never allow you to release into the market. So all the engines you are seeing, they will be passing these tests. Then only they are going to the market side, and we are buying them. So that is how. So if it is a more amount of nitrogen is coming out of the exhaust side, then how they can control? They cannot control, and they have to lean their performance. So lean their vehicle performance. There is no other way around. So what exactly they can do? They will just recirculate the some amount of exhaust gas through this EGR and mix with the intake side. So what it will happen? Some 50% of intake gas will come. Some this 50% of exhaust gas will come. So in exhaust gas, maybe some 5% of oxygen is there, and intake side is a 50% of oxygen is there. Overall, 55% of oxygen will be getting into the intake side. So that's how you are reducing your oxygen component basically, which indirectly reduces the nitrogen component further, right? So in this cycle you might get some 90 mg of nitrogen maybe, but the very next time you might be getting 55 mg only, because there is no more amount of oxygen is not there. So fuel will not be burnt, and obviously less nitrogen. If it is burnt highly, then only more nitrogen will come. Also, with respect to high temperatures, only these nitrogen components will get generated, not at the average temperatures of the engine. That is how the basically this engine complete path of sensors you have seen, different types of sensors you have seen. And you have also seen the exhaust manifold side, that yellow color side, oxygen sensor you had seen, right? So this oxygen sensor is used for calculating the how much amount of oxygen present in the exhaust side. So based on that, they will be deciding how much amount of exhaust gas they can inject back into the intake side. So this is how the IC engines are working. The some of the components I tried to list here: sensors, mass, airflow, intake air temperature, CAC, temperature and pressure. Okay, charge air component it is, and air throttle, intake manifold, EGR. I mentioned exhaust gas recirculation and exhaust manifold and camshaft and crankshaft position sensors and turbo speed sensor and visibility position sensor. So these are all some sensors which I try to mention in the engines. Not only this, there are very many are there in engines. I try to list down the ones which are quite important.